everyone. My name is G. Vishnumurthy. I am working as a contract lecturer in Government Degree College for Women Vanaparthi in the Department of Physics. Today my topic is De Morgan's laws. The De Morgan laws are two. So first one is called as the De Morgan first law and second one is called as the De Morgan second law. De Morgan first law. So the De Morgan first law states that the complement of the sum of the two or more variables is equal to the product of the complement of the variables. That is, for a two input gate, we can write. As for the two input gate, we can write as a plus b bar is equals to a bar dot b bar. A bar dot b bar. From this, we will say that the complement of the sum of the two or more variables. The complement of the sum of the two or more variables are equal to the product of the complement of the variables. Product of the complement of the variables is called as the De Morgan first law. So for the De Morgan first law, we will construct the logic circuit. So here we have the left side. So we have the two terminals like this. And now we are adding we will taking the A and B. Now this A and B are adding. So for the adding purpose, we have the OR gate. So here the OR gate and here the output A plus B. Now we will complement it. So for the complement, we will place the NOT gate in front of the output. So therefore, here we got the output, that is A plus B whole bar. This is the LHS, left hand side. Now it is equals to the equivalent circuit is of the right side, that is A and B. Here A and B. Now we are converting this into A bar, that is for A bar, and this is the B bar. Now here we got the B bar and here A bar. Now we will product between the A bar and B bar. That's why we will take the AND gate. So this is the AND gate. So therefore from this we got the output as y is equals to A bar dot B bar. So this is the circuit about the De Morgan first law. Or also we have the equivalent circuit. So that is AB. So this is, and here place the bubble. That bubble means NOT gate is appearance. So therefore y is equals to A plus B bar. It is equals to, and here taking the another bubble. Bubble means NOT gate is there and for output. So here A bar and here B bar. So y is equals to A bar dot to B bar. So this is the construction of the logic circuit for the De Morgan first law, LHS and RHS. Now we will verify this construction of the circuits are correct or not. So here we will taking the two terminals. So that's why we have the two inputs and here the one output. So for the two inputs, we have the four conditions, that is A, B and 0, 0, 0, 1, 1, 0 and last one is 1, 1. So now we will check for the LHS, that is LHS. LHS means A plus B whole bar. Now we will apply A is equals to 0 and B is equals to 0. So therefore here we got the output as For the NOT gate, the inputs are 0, 0, then the output is equal to 0. Now, this output is connected to the input of the NOT gate, then we have the output as 1. So, this is the one, LHS. For the right hand side, we have A is equal to 0 and B is equal to 0. Now, it will be converting inverse, that is 1, 1, and the output is equals to 1.1, that is 1.1 is equals to 1. So, RHS, that is A bar dot to B bar is equals to 1 for the first condition. Now we are going to second condition. So for the second condition, we have 0, 1, that is 0, 1. So for the output is equals to 1, and now this is converting into 0. So for LHS, 0, now 0, 1. For 0, 1, so here we have the 0 because here 1 dot to 0. So output is equals to 0. Now we are going to third condition, that is 1, 0. For 1, 0, here we are making a 1. And so therefore the output is equals to A plus B is equals to 1. And here we got the output as 1. Output as 1. Sorry, output as 0. Output as 0. Now here we substituting A is equals to 1 and B is equals to 0. So therefore we got the 0 dot to 1. So therefore the output is equal to again 0. Now the last condition, that is 1, 1 condition. So for 1, 1 condition, 1, 1 is equals to the output of the OR gate is equals to 1 and the NOT gate output is equals to 0. Again we got the 0. For this we have the 0, 0 because of here 1, 1. So 0 dot 0 is equals to 0. So now you comparing LHS is equals to RHS, then both are same. So therefore our De Morgan first law will be true. So here you see 1, 1, 0, 0, 0, 0 and 0, 0. So this is the experimental. Now we are going theoretical. For the theoretical, A plus B whole bar is equals to A bar dot to B bar. For the first condition, A is equal to 0 and B is equals to 0. A is equal to 0 and B is equal to 0. Now substitute 0 plus 0 bar is equals to 0 bar dot to 0 bar. Now here 0 plus 0 is equal to 0 bar and here 0 bar is equals to 1 dot 0 bar is equal to 1. 0 bar is equal to 1 and 1 dot 1 is equals to 1. So LHS is equals to RHS for the first condition. Now we are going to second condition, that is A is equals to 0 and B is equals to 1. So we will substituting into this 0 plus 1 whole bar is equals to 0 bar dot to 1 bar. Now here 0 plus 1 is equal to 1 bar is equals to 0 bar is equal to 1 dot 1 bar is equal to 0. Here 1 bar is equal to 0 is equals to 1 dot 0 is equal to 0. Again we got the LHS is equals to RHS. Now for the third condition. So now for the third condition, we have A is equals to 1 and B is equals to 0. Now we are substituting this into this equation. We got as 1 plus 0 bar is equals to 1 bar dot 0 bar. So therefore 1 plus 0 bar is equals to 1 bar is equals to 1 bar is equal to 0 into 0 bar is equal to 1. So 1 bar is equal to 0 again 0 dot 1 is equal to 0. So that's why here also we got the LHS is equals to RHS. And now the last condition, that is the fourth condition. The fourth condition is A is equals to 1 and B is equals to 1. So therefore we will substituting 1 plus 1 whole bar is equals to 1 bar dot to 1 bar. Here 1 plus 1 is equal to 1 bar is equals to 1 bar is equal to 0. 1 bar is equal to 0. So 1 bar is equal to 0 is equal to 0 dot 0 is equal to 0. So again we got the LHS is equals to RHS. That's why hence the De Morgan first law will be verified. Empirically as well as the experimentally, it will be verified. So this is about the De Morgan first law. And for second law, De Morgan's second law. For the De Morgan second law states that the complement of the product of the two or more variables is equal to the sum of the complement of the variables. That is, A dot B whole bar is equals to A bar plus B bar. That means the complement of the product of the two or more variables is equal to the sum of the complements of the variables. So this is called as the De Morgan second. So for the De Morgan second law, we will construct the logic circuit. So here for LHS logic circuit, so taking the two terminals like A, B, now the dot product is there. So dot, and the inversion. So therefore here we got the A dot B, and here we got the Y is equals to A dot B whole bar, and it is equals to, here we will taking the two inputs as A and B. Now we will place the NOT gates, therefore here A bar and here B bar, then we adding. For the adding, OR gate is required. So output Y is equals to A bar plus B bar. This is the logic circuit for the De Morgan second law. Now simplify logic circuit is there. That is, this is the LHS, and for RHS, people. So this is the logic circuit for the De Morgan's second law. Now we are going to we have the two inputs. That's why we have the four conditions. That is A, B, 0, 0, again 0, 0, 0, 1, 1, 0, and last one is 1, 1. For LHS, A dot B whole bar, and RHS, A bar plus B bar. Now for the first condition, A is equal to 0 and B is equal to 0. So A dot B is equals to 0. Now inversion, that is 1. So therefore LHS is equal to 1. Now RHS, A is equal to 0, B is equal to 0. Inversions, that is A bar is equal to 1, B bar is equals to 1. Now output Y is equals to 1 dot 1 is equals to 1. So therefore we got the 1. And now for the second condition, 0, 1. So we making as 1. Now here the output is equal to again 0 into 1 is equal to 0, and the output is equal to again 1. And here we have the 1 and here the 0. So therefore we got the 1 0 is equals to 1 0 is equals to, sorry, 1 into 1 plus 1 plus 1. 1 plus 0 is equals to 1 again. So therefore here we 1 and here the 1. So next third condition, that is 1 0 for 1 0. So here again we got the 0 and here again we got the 1, and here 0 plus 1 is equals to 1. So therefore 1 1. And now the last condition, 1 1. So here we got the output as 1. So from this NOT gate output we have the 0. So LHS is equal to 0. Now here the RHS 1 1. So therefore here the 0 0 0 plus 0 is equals to 0. So 0. So now you comparing LHS is equals to RHS, both are the same 1 1 1 1 1 1 and 0, 0. So that's why the practically or by means of the logic circuit, the De Morgan second law will be verified. Now coming to theoretical explanation. For the theoretical explanation, we will taking as A dot B whole bar is equals to A bar plus B bar. Now for the first condition, A is equal to 0 and B is equal to 0, then we will substitute 0 dot 0 whole bar is equals to 0 bar plus 0 bar. It is 1 bar, sorry, 0 bar is equals to 1 plus 1. Now 0 bar is equal to 1 and it is equals to 1 plus 1 is equal to 1. So LHS is equals to RHS. And now the second condition is A is equal to 0 and B is equals to 1. So therefore, we will substituting as 0 dot 1 whole bar is equals to 0 bar plus 1 bar. Now here you see 0 bar is equals to 1 plus 0. Now here 1 is equals to 1. Again LHS is equal to RHS. Now coming to third, that is A is equals to 1 and B is equals to 0. So therefore we will substituting as 1 dot 0 whole bar is equals to 1 bar plus 0 bar. It is equals to 0 bar is equals to 0 plus 1. It is equals to 1 is equals to 0 plus 1 is equal to 1. Again LHS is equal to RHS. Now coming to fourth one. So that is A is equals to 1 and B is equals to 1. So therefore 1 dot 1 whole bar is equals to 1 bar plus 1 bar. It is equals to 1 dot 1 is equal to 1 bar is equals to 0 plus 0. 1 bar is equal to 0, it is equals to 0. So LHS is equal to RHS. So from this calculation, we will set that A dot B whole bar is equals to A dot B whole bar is equals to A bar plus B bar. So this is about the De Morgan's first and second laws. Now some applications or simplification about the De Morgan's laws. Now we will simplify De Morgan's function. Demorganize the function. Let us say some example, that is demorganize, demorganize AB plus C whole bar. So in this we will taking as the step one as complement the given function, that is sorry, here we will double bar and we will taking as like this, and it is AB plus C whole bar is written as AB bar plus C, which should be written as A dot B, and also it is written as A dot B or A dot B bar plus C. Now it will be written. Now, and the second step is replace by plus and plus by dot. So second step, that is A plus B bar dot to C. Now for the second step, we will remove the dot and we will take the plus, and here we will remove the plus and take the dot product. Now complement the variables, and third step is the complement the variables, that is A bar plus B double bar dot C bar. Now here A bar plus B dot to C bar. C bar. Sorry. So from this we will complementing this. Sorry. Uh, so we have the result as A B plus C whole bar is equals to A bar plus B dot to C. So this is C bar. So this is the demonized. Now another, let us consider another example. Another example is there, that is AB plus BC plus CA whole bar is equals to A bar B bar plus B bar C bar plus A bar C bar. Next, we will taking as this will be written as AB plus BC plus CA whole bar is written as AB plus of BC plus CA whole bar. Now it will be written as AB whole bar. Next dot product, we will taking the dot in place of the plus dot BC plus CA whole bar. Now we will take the common as C. So therefore AB whole bar dot sorry A dot B whole bar is again we will remove the dot as replace the place. So A plus B, that means A bar plus B bar dot sorry another step is there, that is A dot B whole bar, that C is common, so therefore B plus A bar. From this equation we will write as A bar plus B bar, that is from De Morgan's second law, B bar into C bar into C bar plus B plus A bar. Now we will write as A bar plus B bar dot C bar plus B bar dot A bar. Now we will write as multiplication. So therefore we will write as A bar C bar plus A bar B bar plus B bar C bar plus B bar A. From this equation we will write as A bar C bar plus A bar B bar plus A bar B bar plus B bar C bar. Now we will write as A bar C bar plus A bar B bar plus B bar C. Now we will write as A bar B bar plus B bar C bar plus A bar C bar. So this is the correct answer. So this is another example. Now let us see another example for the demorganization or simplifying. That is, let's taking as A plus bar bar plus A dot B bar whole bar plus A bar dot B whole bar total whole bar. Simplifying by using the logical expression. Now we will take as applying De Morgan theorem. We will write as A plus B bar whole bar dot dot A dot B bar whole bar dot A bar dot B whole bar. So from this we will write as A plus B bar dot A bar dot A dot B bar, sorry, A dot B bar dot A bar dot B. So from this equation we will write as A plus B bar bar dot 0 dot 0 is equals to 0. So this is the another example for this one. And now the last example for that demorganization, taking as b dot c dot d plus a dot c dot d. Now we will taking the bar, here bar, and here bar, a bar, and here the bar, and the total bar. Now we will converting this. Now we will apply De Morgan laws as b dot, sorry, b bar plus c bar dot b dot d dot a bar dot c dot d. So from this we will write as a bar b bar c d plus a bar c bar d, then write as a bar b bar c d plus a bar b c bar c bar. Now I will write as a bar b bar c d plus z is equals to a bar b bar c. So this is the simplification, that is the demorganization. సో దీంతోనే మనకు డిమోర్గాన్ సూత్రాలు వాటి యొక్క అప్లికేషన్కి సంబంధించినటువంటి క్లాస్ అయిపోయింది నాన్న. సో దీంతోనే మనకు డిమోర్గాన్ నియమాలు, లాజిక్ గేట్స్, తర్వాత కాంప్లిమెంట్స్, వన్స్ కాంప్లిమెంట్, టూస్ కాంప్లిమెంట్, నెక్స్ట్ కన్వర్జేషన్స్, దట్ ఈస్ డెసిమల్ టు బైనరీ, బైనరీ టు డెసిమల్ కన్వర్జేషన్స్, తర్వాత హెక్సాడెసిమల్ నెంబర్ సిస్టము, తర్వాత అడిషన్, సబ్స్ట్రాక్షన్, మల్టిప్లికేషన్, డివిజన్, కన్వర్జేషన్స్, బోత్ ఆర్ ఆల్ ఆర్ కంప్లీటెడ్ అన్న ఇందులో. సో ఇందులో మనకు ఇంపార్టెంట్ క్వశ్చన్స్ అంటే డిమోర్గాన్ లాస్, తర్వాత లాజిక్ గేట్స్, బేసిక్ లాజిక్ గేట్స్, అండ్ గేటు, నాట్ గేటు, ఆర్ గేటు, ఎక్స్ఆర్ గేటు, యూనివర్సల్ లాజిక్ గేట్స్, దోస్ ఆర్ NAND గేట్ అండ్ నార్ గేట్. సో వీటితో పాటు కన్వర్జేషన్స్, డెసిమల్ నుంచి బైనరీకి, బైనరీ నుంచి డెసిమల్కి కన్వర్జేషను, తర్వాత బైనరీ నెంబర్ను సాధించే విధానము, తర్వాత హెక్సాడెసిమల్ సిస్టమ్ లోపల డెసిమల్ నుంచి హెక్సాడెసిమల్కి, హెక్సాడెసిమల్ నుంచి డెసిమల్కి, మళ్ళీ బైనరీ నుంచి హెక్సాడెసిమల్కి, హెక్సాడెసిమల్ నుంచి బైనరీ లోపలికి మార్చేటివి ఇంపార్టెంట్. సో దీంట్లో మనకు 2 క్వశ్చన్స్ వస్తాయి. సో ఒకవేళ కోవిడ్ ప్యాటర్న్ ఇస్తేనేమో 2 క్వశ్చన్స్ దీని నుంచి కవర్ చేయొచ్చు, దట్ ఈస్ 30 మార్క్స్, చాలా ఈజీగా పాస్ కావచ్చు. లేదు అని అంటే ఓన్లీ సింగిల్ క్వశ్చన్ మాత్రమే రావచ్చు. సో దట్ వాల్యూ ఈజ్ ఈక్వల్స్ టు 15 మార్క్స్. సో ఇంతటితోనే మనకు యూనిట్ 4 అనేది కంప్లీట్ అయింది నాన్న. థ్యాంక్ యూ వెరీ మచ్ అమ్మా.